Dear students, in the previous class I told you about differential calculus, that is the derivative of y with respect to x. So this is I will explain this once again briefly. Here y is a function of x, that means y depends on x. If I plot a graph of y versus x, I will get this type of graph. So this is some curve. So these are the 2 points on this curve, and if I find the slope, it becomes delta y divided by delta x. When this delta x tends to 0, limit delta x tends to 0, that means when delta x is decreasing, correspondingly delta y will also decrease. Then this limit delta x tends to 0, delta y by delta x, which is equal to dy by dx, it becomes the slope of the tangent drawn at a point on this curve. That means derivative of y with respect to x, graphically it gives the slope of the tangent to the curve at a given point. You remember this much. Graphically, derivative will give you slope of the tangent at a given point. Next, mathematically, this dy by dx represents change of y for an infinitesimally small change in value of x. That means when x changes infinitesimally small amount, see delta x tends to 0 means this x is changing very small amount, then the corresponding change in y, it is given by this dy by dx. So mathematically, derivative of a function will give you change of this function with respect to change of the variable. So you just remember this meaning of derivative. Next, for different functions the derivative will be different. I have given various formula which you come across regarding these derivatives while studying this physics. Further, here at this maximum or at this minimum, that means here or here, though x changes, there is no change in y. That means dy by dx, though x changes, there is no change in y. That means this dy becomes 0, so this becomes 0. That means if dy by dx is 0, it represents maximum or minimum. At this maximum or at this minimum, the derivative will become 0. Similarly, if I consider d square y by dx, d square y by dx square, so this will become less than 0 at the maximum, and this becomes more than 0 at minimum. You remember all these points. You also come across them while studying differential calculus in mathematics. So, as far as the physics part is concerned, you need to remember these points. At this stage, even if you could not understand these things, don't worry. You will understand them clearly while studying these things in mathematics. For the time being, you just remember the derivative of different functions, that is enough. The next thing is integral calculus. integral calculus. Here again y is a function of x. If I plot a graph of y versus x, if you get a straight line like this, if you get a straight line AB, if I ask you to find the area under this graph, that means this area. If I ask you to find the area under this graph, what you would do? You take this y length, you take this x length, so this x into this y will give you this area under this graph AB. Very simple. So this being a rectangle, the length into breadth will give you the area. So this is a simple case. So y is a function of x. If you plot a graph of y versus x, if I get a straight line AB like this, when I want to find the area under this graph, I'll take the value of y, the value of x, and when I multiply these two things, I will get this area. Now we shall take a different case. So here there is a graph like this. If I plot y versus x, I got a curve like this. What is the area under this curve? PQ. As it has no definite structure, we can't use any standard formula. So in such a case, what you have to do is, this area under PQ, in order to find the total area under this graph PQ, this entire area is imagined to be divided into large number of elements. Say this distance is A, this distance is B. So let this area is divided into n strips. So this is one strip, this is second one, third one, fourth one, like that. If it is divided into n number of strips, then the width of each strip will become, say, delta x. Let the area be divided into n strips, each of width delta x. Then this delta x can be written as b minus a divided by n. Here this is a, this is b, so this total length will become b minus a. In this length b minus a, there are n number of strips, so therefore the width of each strip will become delta x, which is equal to b minus a. So this is delta x. Each strip is delta x, like this. This y being a function of x, at this particular point P, this height, at this point A, this is FA. So at this point A, this height is FA. Now, what is the area of this strip? It is this FA into delta x. Actually, it won't give exact area of the strip, but neglecting this triangular part, the remaining most part of the area is given by FA into delta x. So this is FA. Similarly, the area of the next strip is, so this is A plus delta x, and this one, the area of this strip is again this height. So this plus this one, this length here. So this becomes a point A plus delta x. So corresponding height will become f of A plus delta x. So this height will become f of A plus delta x, and this will become delta x. So the area of the second strip is FA plus delta x into delta x. So like that you find area of each strip and you make a summation of all these areas, you will get area under the graph, nearly area under the graph. So area of n number of elements, this is equal to, at this point A, the height is FA and width is delta x. I got the area of this first strip. Next, area of second strip, f of, see, up to this point the distance is A, up to this point the distance is A plus delta x. So at this point A plus delta x, the height will become f of A plus delta x. So this is the height of the strip. What is the width? Delta x. So this is the height and this is the width. So these two will give you, product of these two will give you area of the second strip. Similarly, what is this area of this third strip? So this is A plus delta x, and at this point it is A plus 2 delta x. So this height will become f of A plus 2 delta x. This is the height and the width is delta x. Like this. What would be the height of this last strip? This one. That is nth strip. See, for the third strip you have 2 here. For the nth strip you have n minus 1 delta x into delta x. So this will give you the sum of areas of all the rectangular strips. That means neglecting these small triangles, you got the rest of the area under this curve. So area of n number of strips is given like this. Mathematically this can be written as a summation. I is equal to 1 to n f of xi delta x. What is this fxi? So this xi, this term xi is nothing but here a, next a plus delta x, and next a plus 2 delta x, and so on up to n minus 1 delta x. So this xi take all these values. Now this summation can be mathematically written like this. This gives area of all n number of elements. But the area of all these n number of elements, it will be less than the actual area under the curve by an amount equal to area of all these triangles. So ಇಲ್ಲಿ ಈ ಲೆಂತ್ ಇಂಟು ಬ್ರೆಡ್ತ್ ಮಾಡಿದರೆ ಇದೊಂದೇ ಸ್ಟ್ರಿಪ್ದು ಏರಿಯಾ ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ಫಾರ್ ದ ಫಸ್ಟ್ ಸ್ಟ್ರಿಪ್, ಫಾರ್ ದ ಸೆಕೆಂಡ್ ಸ್ಟ್ರಿಪ್, ಥರ್ಡ್ ಸ್ಟ್ರಿಪ್, ಈ ರೀತಿ ಎಲ್ಲ ಸ್ಟ್ರಿಪ್ಸ್ದು ಏರಿಯಾಸ್ನು ಆ್ಯಡ್ ಮಾಡಿದಾಗ ಈ ಟ್ರಯಾಂಗುಲರ್ ಏರಿಯಾ ಬಿಟ್ಟು ಉಳಿದಿರೋ ಏರಿಯಾ ಎಲ್ಲ ಬಂದಿರ್ತದೆ ನಿಮಗೆ. ಸೊ ಟೋಟಲ್ ಏರಿಯಾ ಅಂಡರ್ ದ ಕರ್ವ್ ಅಂತ ಹೇಳಿದಾಗ ನಿಮಗೆ ಟೋಟಲ್ ಏರಿಯಾ ಬರಬೇಕು, ಬಟ್ ಈ ಟ್ರಯಾಂಗುಲರ್ ಏರಿಯಾ ಮಿಸ್ ಆಗ್ತಾ ಇದೆ. ಅಂದರೆ ಇದು ನಿಮಗೆ ಟೋಟಲ್ ಏರಿಯಾ ಕೊಡ್ತಾ ಇಲ್ಲ. ಸೊ ದಿಸ್ ಏರಿಯಾ it will be less than the actual area under the curve PQ. So in order to get the exact area under the curve PQ, what we do is we assume that there will be n number of, we shall take this delta x to be very very small, delta x tends to 0. So if delta x tends to 0, that means if width of each strip is infinitesimally small, delta x tends to 0 means width of each strip becomes infinitesimally small. So infinitesimally small means it is very very small, which is almost equivalent to 0. That's what you mean by delta x tends to 0. So if width of each strip is infinitesimally small, then the number of strips, it becomes infinity. Understand? Say for example, this is an object. If I take a length, if I take strips of 1 centimeter length, ನಾನಿಲ್ಲಿ ಈ ಟೋಟಲ್ ಲೆಂಗ್ತು 10 ಸೆಂಟಿಮೀಟರ್ ಇದೆ ಅಂತ ಇಡೀರಿ. ನಾನು 1 ಸೆಂಟಿಮೀಟ್ರದ್ದು ಒಂದು ಸ್ಟ್ರಿಪ್ ತೊಗೊಂಡ್ರೆ ಎಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಇರ್ತಾವೆ? ಇಲ್ಲಿ 10 ಇರ್ತಾವೆ. ನಾನು ಒಂದೊಂದು ಸ್ಟ್ರಿಪ್ಪು 0.5 ಸೆಂಟಿಮೀಟ್ರ್ ತೊಗೊಂಡ್ರೆ ಇಲ್ಲಿ 20 ಎಲಿಮೆಂಟ್ಸ್ ಇರ್ತಾವೆ. ಒಂದೊಂದು ಸ್ಟ್ರಿಪ್ಪು 0.25 ಸೆಂಟಿಮೀಟ್ರ್ ತೊಗೊಂಡ್ರೆ ಈ 10 ಸೆಂಟಿಮೀಟ್ರ್ನಲ್ಲಿ 40 ಎಲಿಮೆಂಟ್ಸ್ ಬರ್ತಾವೆ. ಅಂದರೆ ಒಂದೊಂದು ಸ್ಟ್ರಿಪ್ ಬಿಟ್ಟು ಕಡಿಮೆ ಹೋಗ್ತಾ ಇದ್ದಂಗೆಲ್ಲ ನಂಬರ್ ಆಫ್ ಸ್ಟ್ರಿಪ್ಸ್ ಜಾಸ್ತಿ ಹಾಕೊಂತ ಹೋಗ್ತಾವೆ. ಸೊ ಇಲ್ಲಿ ಈಚ್ ಸ್ಟ್ರಿಪ್ ವಿತ್ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಇದ್ದಾಗ ನಂಬರ್ ಆಫ್ ಸ್ಟ್ರಿಪ್ಸ್ ಆರ್ n. If delta x tends to 0, then n becomes equal to infinity. So under such condition, the actual area under PQ, it can be written as integral, this I ranges from 1 to n, here n is infinity, fxi delta x. That means this limited summation, it becomes infinite summation. Understand? So here the summation is 1 to n. When delta x tends to 0, n tends to infinity. Therefore the summation will become infinite summation. This infinite summation, it is represented as integration. So integration, it is symbolically written as elongated s. Generally we write s like this. When you elongate it, it becomes a symbol for integration. So this symbol is to be pronounced as integral. So integral fx dx, we write it like this. So this integration is to be carried within the limits from a to b. So here when you use these limits, then this can be called as a definite integral. So this area A, it is represented as integral a to b fx dx. So this will give you the area under this curve PQ. So when you make this integration, here as infinite number of elements are there from a to b, even these small triangular areas will also be included while finding this total area under PQ. ಸೊ ನೀವು ಇದನ್ನು ಯೂಸ್ ಮಾಡಿದರೆ ಈ ಟ್ರಯಾಂಗುಲರ್ ಏರಿಯಾಸು ಇನ್ಕ್ಲೂಡ್ ಆಗಿರೋದಿಲ್ಲ. ಬಟ್ ಈ ರೀತಿ ಇಂಟಗ್ರೇಷನ್ ಮಾಡಿದಾಗ ಪ್ರತಿಯೊಂದು ಸ್ಟ್ರಿಪ್ನು ಭಾಳ ಸ್ಮಾಲ್ ವಿಡ್ತ್ ಇರೋದರಿಂದ ದ ಏರಿಯಾ ಆಫ್ ಈಚ್ ಟ್ರಯಾಂಗಲ್ ಬಿಕಮ್ಸ್ ಆಲ್ಮೋಸ್ಟ್ 0. ಸೊ ದೆರ್ಫೋರ್ ಇಟ್ ಗಿವ್ಸ್ ದ ಟೋಟಲ್ ಏರಿಯಾ ಅಂಡರ್ ದ ಕರ್ವ್ PQ. So when you integrate this function, you will get some other function like this. When you integrate fx with dx, you will get a gx. So for this gx, these are the limits a to b. So therefore, in this function, first you have to subtract the upper limit, subtract it. You have to substitute the upper limit, subtract it, and substitute the lower limit. So ಈ ಎಫೆಕ್ಸ್ನು ಇಂಟಗ್ರೇಷನ್ ಮಾಡಿದ ನಂತರ ಏನು ಬರುತ್ತೋ ಈ ಫಂಕ್ಷನ್ನಲ್ಲಿ ಫಸ್ಟ್ ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, ಸಬ್ಟ್ರಾಕ್ಷನ್ ಸೈನಿಂದ ಈ ಲೋವರ್ ಲಿಮಿಟ್ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬೇಕು. ದಟ್ ಗಿವ್ಸ್ ದ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿಸ್ ಏರಿಯಾ. ಸಿ ಫಿಸಿಕಲಿ integration means infinite summation of infinitesimally small elements. So ಇಲ್ಲಿ this delta x is a small element. When you make a infinite summation of small elements, that becomes integration. So you blindly remember this statement. Integration is nothing but infinite summation of smaller elements. See, differentiation and integration, they are quite opposite process. Differentiation ಅಂತಂದರೆ ಯಾವುದೇ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆದರೆ ಇನ್ನೊಂದು ಎಷ್ಟು ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆಗುತ್ತೋ ಅದರದ್ದು ರೇಟ್ dy/dx ಈಸ್ ಕಾಲ್ಡ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್. ಇಂಟಗ್ರೇಷನ್ ಅಂತಂದರೆ ಇನ್ಫೈನೈಟ್ ನಂಬರ್ ಆಫ್ ಸ್ಮಾಲ್ ಎಲಿಮೆಂಟ್ಸ್ನು ಆ್ಯಡ್ ಮಾಡೋದನ್ನೇ ಇಂಟಗ್ರೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಇಂಟಗ್ರೇಷನ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಎ ಸಮ್ಮೇಷನ್. ಇಟ್ ಈಸ್ ಎ ಇನ್ಫೈನೈಟ್ ಸಮ್ಮೇಷನ್ ಆಫ್ ಸ್ಮಾಲರ್ ಎಲಿಮೆಂಟ್ಸ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? See, this is a common word, integration. You might have heard of national integration. That means making the nation one. In nation there are so many people having different interests. But when you take nation as a one, we call it as national integration. So it's a common word. So integration is nothing but a summation. So here it is called infinite summation. Just as you have seen in case of differentiation, in case of integration also, for different functions, for different functions of fx, the integration will be having different values. So you remember the following formulae regarding this integration. So integral x to the power of n dx. Integral x to the power of n dx, it is x to the power of n plus 1 divided by n plus 1. Similarly, integral see, this formula becomes true only when n is not equal to minus 1. When n becomes equal to minus 1, this is not valid. Similarly, integral 1 by x dx. So this is log x. This is valid when x is equal to 0. Under this condition only, x is greater than 0. Next, integral sin x dx. This becomes minus cos x. Integral cos x dx, it is sin x. Integral e to the power of x dx, it is e to the power of x. So in the study of physics you come across this formula. So you remember this formula. Next, the process of integration and differentiation, they are opposite to each other. See here, integral of fx dx, you will get gx. If I integrate this function, you will get this function. If I differentiate this function, integral of gx with respect to dx, it will become fx. ನೀವು ಇದನ್ನು ಡಿಫರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದರೆ ಇದು ಬರ್ತದೆ, ಇದನ್ನು ಇಂಟಗ್ರೇಟ್ ಮಾಡಿದರೆ ಇದು ಬರ್ತದೆ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ವೆನ್ ಯು ಡಿಫರೆನ್ಷಿಯೇಟ್ gx, you will get fx. When you integrate fx, you will get gx, because integration and differentiation, they are reverse processes. To understand this, I will take one simple example. Here you take this one. See, I said that d by dx of x to the power of n, it is nx to the power of n minus 1. This is a function gx, this is function gx. When you differentiate it, I got this function fx. ಇಲ್ಲಿ x to the power of n ಅನ್ನೋದು gx. x to the power of n is nothing but gx. When I differentiate this with respect to x, I got this one. This is the formula for d by dx of x to the power of n. Now, if I integrate this fx, ಇದನ್ನು ನಾನು ಇಂಟಗ್ರೇಟ್ ಮಾಡಿದರೆ, integral of n x to the power of n minus 1 dx, ಇದನ್ನು ಇಂಟಗ್ರೇಟ್ ಮಾಡಿ ಅಂತ ಹೇಳಿರಿ. ಇಲ್ಲಿ n is a constant. So, integral of x to the power of n minus 1 dx. So, according to this formula, ಇದು ಈ ಫಾರ್ಮುಲಾ ಪ್ರಕಾರ integral of x to the power of n dx is x to the power of n plus 1 by n plus 1. If I apply this, so this is n now plus 1 divided by n plus 1. So ಇದು cancel ಆಗುತ್ತೆ, ಈ n cancel ಆಗುತ್ತೆ, you will get x to the power of n. So, differential of gx, you will get fx. Integral of fx, you will get gx. Because differentiation and integration, they are opposite processes. You take one more example. Differential of sin x is cos x. Differential of d by dx of sin x is cos x. What is integral of cos x? It becomes sin x, because they are reversible. Integration and differentiation, they are opposite processes. That is why differential of a function, whatever you get, if you integrate, you will get back the same function. Next, in the study of physics, you come across this integration oftenly. Physics study ಮಾಡುವಾಗ majority of the numerical problems and majority of the long answer type questions, they involve this integration. ನೀವು ಬೋರ್ಡ್ ಎಕ್ಸಾಮಿನೇಷನ್ನಲ್ಲಿ 5 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸ್ ಏನಿರ್ತವೋ ಆ 5 ಮಾರ್ಕ್ ಕ್ವಶನ್ಸ್ನ ಆನ್ಸರ್ ಮಾಡುವಾಗ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಿ ಆನ್ಸರ್ ತರಬೇಕಾಗತ್ತೆ. ಅದೇ ರೀತಿ JEE ಮೇನ್ಸು ಮತ್ತು JEE ಅಡ್ವಾನ್ಸ್ಡು ಎಕ್ಸಾಮಿನೇಷನ್ಸ್ನಲ್ಲಿ ಕೆಲವು ಕ್ವಶನ್ಸ್ ನೀವು ಆನ್ಸರ್ ಮಾಡಬೇಕು ಅಂತಂದಾಗ ದ ನಾಲೆಡ್ಜ್ ಆಫ್ ಇಂಟಿಗ್ರೇಷನ್ ಈಸ್ ವೆರಿ ಮಚ್ ಎಸೆನ್ಷಿಯಲ್. ಸೊ ನಾನು ನಿಮಗೆ ಇಲ್ಲಿ ತನಕ ಇಂಟಿಗ್ರೇಷನ್ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಬಗ್ಗೆ ಏನು ಹೇಳಿದನೋ ಅದು ನೀವು ಸರಿಯಾಗಿ ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ಸರಿ. ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತಂದರೆ ಅಟ್ಲೀಸ್ಟ್ ಫಾರ್ಮುಲಾಗಳಾದರೂ ಕರೆಕ್ಟಾಗಿ ನೆನಪಿಟ್ಕೊಂಡಿರಿ. ಫಾರ್ಮುಲಾಗಳು ನೆನಪಿದ್ರೆ ನೀವು ರೆಸ್ಟ್ ಆಫ್ ದ ಥಿಂಗ್ಸ್ ಯು ಕ್ಯಾನ್ ವರ್ಕೌಟ್ ಇನ್ ಫಿಸಿಕ್ಸ್. ಬಟ್ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ನಲ್ಲಿ ಮಾತ್ರ ಇಂಟಿಗ್ರೇಷನ್ ಮತ್ತು ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಇದನ್ನು ಸರಿಯಾಗಿ ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ಈ ಉಳಿದಿರೋದು ನೀವು ಫಿಸಿಕ್ಸ್ನಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ಸ್ನು ಎನಿ ಟೈಪ್ ಆಫ್ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟರು ಈಸಿಯಾಗಿ ಮಾಡೋಕ್ಕೆ ಬರುತ್ತೆ. ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ Here this is 1, 2, 3. There is a body here at 1. A constant force of 10 Newton acts on the body and moves it up to here. So on the x-axis, this is the horizon. On the x-axis, there is a body at x is equal to 1. A constant force of 10 Newton acts on the body and displaces to this 3 units in the x direction. So, what is the displacement due to the force? From here to here it is 1 unit and from here to here it is 3 units. So, displacement is 2 units, say 2 meter. If I consider this as meter, so displacement is 2 meter. So, what is the work done by the force? Work done by the force is nothing but force into displacement. That means this 10 into 2, which is equal to 20 joule. Because at school level you have learned that work done is nothing but product of force and displacement along the direction of force. So this formula is applicable only when the force is a constant force. In case if the force is variable, then you can't do the calculation like this. You can't do the calculation like this. You take a different situation. Here, a variable force acts on a body at x is equal to 1 meter. This variable force, it varies with the distance. It is given by x square plus 1 Newton. There is a variable force which varies with the distance. So this variable force is given like this. So a variable force acts on the body. What is the work done by the force while the body displaces through 3 meter? The examination question will be asked like this. Understand? There is a body at x is equal to 1 meter. A variable force which is x square plus 1 Newton acts on the body and displaces it to 3 meter. What is the work done by the force? ಅಂತ ಕೇಳ್ತಾರೆ ಎಕ್ಸಾಮಿನೇಷನ್ ಅಲ್ಲಿ. ಆವಾಗ ನೀವು ಸಿಂಪ್ಲಿ W is equal to F into S ಅಂತ ಮಾಡಿದರೆ ಬರಲ್ಲ. ಸೊ ಇಲ್ಲಿ this work done in displacing the body, it is given by F into dx. So what is the total work done in displacing it from 1 to 3 meter? It is integral W is this W is equal to integral dW from 1 to 3. So it is integral 1 to 3 F dx. So integral 1 to 3 x square plus 1 dx. It's like this. So if I integrate this one, so idunu integral 1 to 3 x square dx plus integral 1 to 3 dx. We'll get it like this. So integral x square will become x cube divided by 3. So this integral dx, it will become x1 to 3. So first I substitute this upper limit. In place of x you take 3. So it is 3 cube divided by 3 minus 1 cube divided by 1. Or otherwise, simply you can also write that 3 cube minus 1 cube divided by 3. You can also write it like this. Here 3 minus 1, it is simply 3 minus 1, because this is the first upper limit is 3 minus lower limit is 1. So this is 27 minus 1, 26 plus 2. So if I take LCM, 26 plus 6 divided by 3, so this becomes 32 divided by 3 joule. So I have to do the calculation like this. So when the force is a variable, work done F into S, force into displacement, though conceptually it is correct, simply you can't use that relation because the force being a variable, work done in displacing by a small amount. See, in a small distance dx, in a small distance dx, though force is variable, it is considered to be a constant. So it becomes F into dx. And the total work in displacing this small amount dx, this is the work done. In displacing from here to here, total work done means you have to integrate between the limits 1 to 3, this detail. So by this procedure, you will get that much. You come across these type of problems frequently in the study of PU1 physics as well as PU2 physics. And also, so this is all about this integral calculus and differential calculus. Sometimes while solving numerical problems, you also come across progressions, arithmetic progression and geometric progression like this. You study this arithmetic progression as well as the geometric progression in PUC first mathematics. So a series of this form, A plus D, A plus 2D, A plus 3D, like this. A series of this form, it is called arithmetic progression. This A is called the initial term and this D is called the common difference. A is called initial term and D is called common difference. If there are n number of terms, what is the nth term? This is the first term. For second term 1D is there. For the third term 2D is there. For the fourth term 3D is there. Like that. This nth term n minus 1D will be there. So in AP arithmetic progression, this nth term an, this can be written as A plus n minus 1 into D. While solving some problems, particularly in tuning forks, when number of tuning forks are arranged successively, beats will be given and what you will be asked to find what is the frequency of the first tuning fork or last tuning fork. While solving such type of problems, if you have this idea, it becomes easy to solve those problems. So a series of this form, it is called as arithmetic progression. In this arithmetic progression, the nth term is given by A plus n minus 1 into D. And also, when I add all these terms, that is called sum of the terms, Sn. This is given by n by 2. A plus n, it is nothing but arithmetic mean. So this is the sum of n terms is given by this equation. Similarly, you also come across problems involving this geometric progression, GP, geometric progression. See, terms of this order, AR square, AR cube, AR to the power of 4, like that. Terms of this form, they are said to be in geometric progression. And here this R is called common ratio. If I find the ratio of these two terms, these two terms, these two terms, these two terms is same, which is R. So as we say, this is common difference, because if I subtract this term from this, this term from this, this term from this, you get D. That's why it is called common difference. In the same way, this R is called common ratio. R is called common ratio. So here this nth term. So in this series, if n terms are there, what would be the nth term? An. Here you see, for the second term r power 1 is there. For the third term r power 2 is there. For the fourth term r power 3 is there. Like that, for the nth term r power n minus 1 will be there. So this is the nth term in this geometric progression. Similarly, the sum of n terms. Sum of n terms in geometric progression, that is given by this Sn is equal to a into 1 minus r power n divided by 1 minus r, or sometimes the terms may change like this. See, if you become familiar with all these mathematical relations, then the study of physics becomes very simple. If you understand all these mathematical relations, it is well and good. Even if you could not understand, don't get scared. ನಾನು ಕಳೆದ 3 ಕ್ಲಾಸಿಂದ ಏನೇನು ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ ರಿಲೇಷನ್ಸ್ ಅಂತ ಹೇಳಿದ್ದೀನೋ ಅವು ನಿಮಗೆ ಅರ್ಥ ಆದರೆ ಸರಿ, ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತಂದರೆ ಹೆದರ್ಕೋಬೇಡ್ರಿ, ಹೆದರೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಈಗ ಟೈಮ್ ಬೀಂಗ್ ನೀವು ಫಾರ್ಮುಲಾಗಳು ನೆನ್ಪಿಟ್ಕೊಂಡ್ರಿ, ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ನಲ್ಲಿ ಇವೆಲ್ಲ ಇನ್ನೊಮ್ಮೆ ಬರ್ತಾವು. ಆವಾಗ ನೀವು ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ನಲ್ಲಿ ಥರೋ ಆಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ದ ನಂತರ ಇವೆಲ್ಲ ಫಿಸಿಕ್ಸ್ನಲ್ಲೂ ಭಾಳ ಈಸಿಯಾಗಿ ನಿಮ್ಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ತಾವೆ. ಹಾಗಾಗಿ 3 ಕ್ಲಾಸಿಂದ ಸರ್ ಏನೋ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ನಮ್ಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ, ಮುಂದೆ ಹೆಂಗಿರುತ್ತೋ ಏನೋ ಆ ಥರ ಹೆದರ್ಕೋಬೇಡ್ರಿ. ದೇರ್ ಇಸ್ ನಥಿಂಗ್ ಟು ವರಿ. ವಿ ಆರ್ ದೇರ್ ವಿತ್ ಯು ಆಲ್ ದ ಟೈಮ್ ಟು ಹೆಲ್ಪ್ ಯು. ಸೊ ಈ ಥರ ಸ್ಪೆಸಿಫಿಕ್ ರಿಲೇಷನ್ಸ್ನಲ್ಲಿ ನಿಮಗೆ ಏನಾದರೂ ಡಿಫಿಕಲ್ಟಿ ಇದ್ದರೆ ನಾವು ಹೇಳ್ಕೊಡ್ತೀವಿ, ಅದರಲ್ಲಿ ಚಿಂತೆ ಇಲ್ಲ. ಬಟ್ ಭಾಳ ಜನ ಎಲಿಮೆಂಟ್ರಿ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ಬರಲ್ಲ, ಅದು ದಟ್ ಈಸ್ ದ ಮೇನ್ ಪ್ರಾಬ್ಲಮ್ ಇನ್ ಫಿಸಿಕ್ಸ್. ಎಲಿಮೆಂಟ್ರಿ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸ್ ಅಂತಂದರೆ ಈ ಫ್ರ್ಯಾಕ್ಷನ್ಸ್ ಬಂದಾಗ ಕ್ಯಾನ್ಸಲೇಷನ್ ಮಾಡಿ ಆನ್ಸರ್ ಬರೆಯೋದು, ಆಮೇಲೆ LCM ತೆಗೆದು ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡೋದು, ಈ ಪವರ್ಸ್ ಇದ್ದಾಗ ಥಿಯರಿ ಆಫ್ ಇಂಡಿಸೀಸ್ನ ಯೂಸ್ ಮಾಡಿ ರಿಸಲ್ಟೆಂಟ್ ಪವರ್ ಎಷ್ಟು ಬರುತ್ತೋ ಅದನ್ನು ಬರೆಯೋದು, ಇಂಥದ್ದು ಬೇಸಿಕ್ಸಲ್ಲಿ ನೀವು ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತೀರಿ. ಅಂಥವು ಹೇಳ್ಕೊಳಕ್ಕೆ ಆಗಂಗಿಲ್ಲ, ಯಾಕಂದರೆ ಅವೆಲ್ಲ ನೀವು ಸ್ಕೂಲಿಂದ ಮಾಡ್ತಾ ಬರ್ತಾಯಿದ್ರಿ. ಮಲ್ಟಿಪ್ಲಿಕೇಷನು, ಎಡಿಷನು, ಡಿವಿಷನು ಇವೆಲ್ಲವೂ ನೀವು ಸ್ಕೂಲಿಂದ ಕಲಿತಾ ಇದ್ದೀರಿ, ಅವೆಲ್ಲ ಹೇಳ್ಕೊಳಕ್ಕಾಗಲ್ಲ ಈ PU ಲೆವೆಲ್ನಲ್ಲಿ. ಬಟ್ ಈ ಥರ ಸ್ಪೆಸಿಫಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಏನು ಬರ್ತಾವೆ ಇವನ್ನ ನಾವು ವಿ ಕ್ಯಾನ್ ಮೇಕ್ ಯು ಕ್ಲಿಯರ್. ನೀವು ಬೇಸಿಕ್ ಮ್ಯಾಥಮ್ಯಾಟಿಕ್ಸು ಸ್ಟ್ರಾಂಗ್ ಆಗಿದ್ದರೆ ಇವೆಲ್ಲವೂ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗ್ತಾವೆ. ಸೊ ನಿಮಗೆ ಈ ಅರ್ಥ ಆಗಲಿಲ್ಲ ಅಂತಂದರೆ you refer all the mathematics what you studied from 6th, 7th, 8th, 9th and 10th. ಅವು ಪರ್ಫೆಕ್ಟ್ ಆಗಿರಿ, ಆಮೇಲೆ ನಿಮಗೆ ಫಿಸಿಕ್ಸ್ ಸ್ಟಡಿ ಮಾಡೋದು ಭಾಳ ಈಸಿ ಆಗುತ್ತೆ. ನಿಮಗೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ನಲ್ಲಿ ಎಲ್ಲರಿಗೆ ಲಾಗರಿಥಮ್ ಬುಕ್ ತೊಗೊಳಕ್ಕೆ ಹೇಳಿದ್ದೀನಿ. ನೀವು ನೆಕ್ಸ್ಟು ಲೆಕ್ಚರ್ ಕೇಳುವಾಗ ಆ ಲಾಗರಿಥಮ್ ಬುಕ್ಕು ನಿಮ್ಮ ಹತ್ರ ಇಟ್ಕೊಂಡಿರಿ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ನಲ್ಲಿ ನಾನು ಲಾಗರಿಥಮ್ಸ್ ತೊಗೊತೀನಿ. ಬಾಯ್.